All right, everybody, it's time for the 10th, measures of center and spread. We have two measures of center, mean and median. We had no assignments today. Mean has two symbols for it, depending on if you have a sample or a population. The mean is all the numbers added up. The mean is the middle number. The mean is good for mound-shaped data and histograms. It's really bad for outliers and skew. The outliers will pull the mean really far towards them. And so it's called, the word for that is not resistant. It does not resist outliers. Whereas the median is good for dealing with outliers. It's very resistant to outliers because all an outlier does is just move the middle point over one notch. Oh yeah, and then the median is really good for box plots. It's literally the middle line in a box plot, which is cool. Measures of center and here's measures of spread. So we have three of them we use. IQR, that goes on a box plot. Q3 minus Q1, that's the box part. That's another resistant measure. Resistant because it deals with the median and it does not get pulled away by outliers. Standard deviation is the average distance away from the mean of all your points. And that's the gist of how to find it. But what's more important to remember is if the standard deviation is high, your points are more spread out. And if your standard deviation is low, then they're close together. There's two symbols for this one as well, one for population, one for sample. And it's not resistant at all. It's actually found when using the mean. So the mean is not resistant, meaning the standard deviation is not resistant. So again, standard deviation is really good for like mound-shaped data. It has all sorts of awesome rules that go with it, but we'll get to those later. Range is your last resort if you're using SOCS. It's just max minus min. You guys have all seen it before. And then that's all the new notes for today. We also talked a little bit about the shape of box plots, which we'd probably add tomorrow.